Hello, and now I would like to comment on the Lab 4's assignment 2. So let's check the requirement first. We have and define adult.csv and have around 15 features from age to income level. Now this one is a real file, and we can see that there's no header. Okay, then the first requirement is to use the ggplot to make a scatter plot of hour per week versus age where observations are colored by income level. So we load the data first using read.csv and also set the header to source and a separate symbol using this, as we can see from here. And then because it's the original file don't have the header, so we need to set the column by hand. Then we set the income level using the function trim.ws. Then we set another new feature called income color and set its value to 1 if it's a high income level, and set the value to 0 if it's a low income people. And then we use ggplot and to plot it. We can see from here it's good. But I also found the issue that he just using the 0 and 1 as here, which means the user cannot know what the 0 and 1 really means if they don't check the code. So it's better to change this one to a human readable string, not just 0 and 1. Then then we need to make a status plot and based on the income level. And here we can using the ggplot and using phased grid and using income level as parameter to split this plot into two. Okay, we can from this plot we can see that the low income people are the working age from around 10 to maybe from 75. And for high income people, the working age from around 25 or 24 to around 60. Okay, and about working hour per week for the low income people, working hour per week around 0 to 60. Okay, and that means someone may be jobless, and or maybe just a part-time. Here, the high income level, high income people, their working hour is around to 30 to 60, I think. So based on the information like this, we can do the next part, which is comment. So we would like to what new conclusion can you make here? So this team's comment is like this. From the scatter plot, we can conclude there are more people having less 50K, and also we can see a small cluster of most people having less than 50 years are putting 25 to 50 hours a week. For the first part of sentence, I agree, because we can check from because this one is a mix of the blue one and green one and the red one. But from here we can clearly see that more people here because more points and less people here. So I agree with the first one, but the second part we we can see the small cluster. That means having less than 50 years of age are putting 25 less than 50 years and working 25 to 50 hours a week. That means from this plot we can see that 25 to 50 it's hard to say that, because at least if we would like to say that we should go here, which is around 60. maybe 55, so it's not proper. And also for the hours, 25 to 50. 25 to 50, but I think this one and this one are the same, so we cannot see that. So I think this one is not, the second part of the first sentence is not proper. Okay, where people are getting high salary put more hours than 25. Okay, this one is correct. Okay, because this one is a line here, maybe 30, I think. So then Talus plot, Talus graph, but I think from here we cannot say that. So, but from here it's very clear. So it's better not right here, maybe right at the bottom in the Talus plot. So Talus plot depicts clearly that more people having less salary. They are from 25 to 50 years, which means year 25 to year 50, more people have less. 25 to 50, yes, we can say that, but we also should mention here, because more people began to work in the age around 10 to 25, and here almost no people in here. So I think this analysis is not complete. Should write more about the data. And also I think it's better to using different colors, not using the same color as this one, which means one is low income people and one is high income people. That means we should using the green one here, green one here and red one here. So to make the same color. Okay, then question 2. Using ggplot to create a density plot of the age grouped by the income level. Okay, so let's select the age, income level, marriage status, and group by all of them, and then summarize to get the count, and then ggplot the density plot like this. Okay, then this team, this group also using ggplot and the phased grid to draw Talus plot. Okay, but I also found something which is not proper. Okay, because we already you know, just like here, we already using the income level, and we already have age and marriage status, because we have a marriage status here. So it's better to split the this curve to two curves using the Talus plot. And here is my report. And based on the different income level, we can see that for the low income people and the high income people, they have different distribution. And for high income people, we can see that the density plot is almost systematic. It's symmetrical distribution, but this one is for low income people has a wide screwed tail. That means this you know, high income people have a mean value around maybe 40, but this one low income people have a, you know, mean value around 25 or 24. So they have different distribution. So if we only using one curve to demonstrate to show the result, it may miss miss a lot of information. And yes, which means we can using the data to explain more patterns, to find more patterns. And also about the tensor plot, they're also using the dot plot to show different measure status. But if we convert this dot plot to the density plot or like this, we can see more clear patterns. For example, we can see that for divorced and marriage AF response, marriage CIV response, separated, and the last one, the income level, for the high level income and low level income people, they almost share the same pattern. But for never married and married response absent, they show the pattern of this one. Okay, so from this one we can find a more clear pattern from the origin data. So let's check the comment of this question. Does the plot tell us the people getting salary mostly between 20? Let's check. Okay. Does the plot tell us the people getting a salary mostly between 25 to 60? But it's hard to say that because here we still have a lot of things here. So it's better to analyze plot by plot, not just say this. Here, okay, yeah, sorry. This one we can see that, yeah. But where the tensor plot shows the marriage status, most of the people are getting less than 50k. 50k. We can say that, but for this one, because most of them are same, but it's very hard to say that because there may be only one or two points missing. Okay, and then that's all its comment, or there's comments, so I think it's not complete. Maybe we can write more about that and not using this dot plot, using the curve or the density plot instead. So here, the third one. Third one, the requirement is filter out all the observation not equal to 0. And for the remaining data, use the plot tree to create a 3D scatter plot. And then tell why it's difficult to analyze this plot. Okay, so first of all, we need to find out the capital loss is not equal to 0. So it's better to use not equal to 0 instead of greater than 0. But luckily all the data in the origin data is a positive value or 0, so in this case it's okay, but it's better to use not equal to 0. Then we create a new feature, age group, and then cutting number, and cut this age to 6 groups. Then we're using plot array and set all the parameters and set the x and y and z, and this one is the plot. Okay, so this one, this plot do not have a big issue, but but still have one small issue, which is this point too big. Which even we rotate, we can see a clear pattern. So my suggestion is we should set the point to a smaller scale, just like this. So when we rotate, maybe we can find some patterns. Okay, so the code is here. So 2.3, I think. Which is here, side equals 0.2. Okay, So then we draw a TALIS plot, still using ggplot. Okay, then using the density plot, and the key function is the phased WAP, and using age group we can see some here. And the comment is we only see the cluster in the middle for the capital loss of around range 50,000, 1,500 to 2,000 between age 30 to 65. Okay, let's just 30 to 65. Yeah, here. And okay, then but we can see, yes, he only mentioned here, and capital loss is around 1,005. Okay, but we can find more things here. We can find that, you know, this one, and this one share the same pattern. This one and this one almost share the same pattern, so we can also mention this. Then so maybe we can write more things about that, not just this. Okay, then the next requirement is make a TALIS plot of containing 4 panels, where each panel should show a scatter plot of capital loss versus education number. Okay, then using shringless with 10% overlap, and then show the chronicles of this. So here we first of all using to create age group, and using cut number and the 2 4 groups, and using a phase WAP, and this parameter is age group. So this one no problem, I think. Then we need also using 10% overlap. So the code here is I check it, it's no problem. Okay, the first of all we using the equal.count to make the range of each range with overlap of 10%. Then we get the lower and upper of each range. Then use a for loop to get its class. Okay, and then we then based on the data we using the ggplot to plot all of them. But the thing is, okay, we also need to which advantage and disadvantage you show using the shingles. So in shingles, it's good to solve the solve that kind of point in between. For example, if one point, okay, and the point before that is a very low value, and the point after that is a very high value. That means there's a jump here. So using the shrinkles, we can see that we can handle this. But the shortcoming is the disadvantage is it will increase the calculation cost, which is not good, and we don't want to see that. And also because overlap, creates a complexity when we do some calculations. Yes. So that means this team forgot to answer this question. So yeah, we should add more things here. And another one I would like to add, comment on this is there's no document here, so it's better to write a comment. Okay, that's end of this assignment 2. Thank you.